Hello everyone, my name is Adrian and today I'm going to talk about the integral formula for arc length.
Alright, so when we talk about an arc length, we're essentially asking how long is the curve between 2 points. Now, when we deal with a straight line, this is simple since we can just use the distance formula. But for a curve, like a parabola or sine wave, the path is bending. So we need a formula that accounts for all those small changes, and this is where the formula for arc length comes into play. When taking a look at the formula, L is the arc length. The integral is summing up all the little pieces of length along the curve. Inside the square root, the term 1 comes from the horizontal distance, and dy dx squared comes from the slope, or how steep the curve is. Let's work through an example so we can see how this works. Remember, our goal is to find the arc length of this curve from 0 to 1. First, we want to take the derivative of dy over dx equals 2/3 times 3/2 times x raised to the 1/2 power. Here, the constants cancel out, leaving us with square root of x. Now, we can plug this into the arc length formula, and when we do so, we get L, which equals to the integral from 0 to 1 of the square root of 1 plus dy over dx squared dx. If we substitute the square root of x, we get x. So now we have L, which equals to the integral from 0 to 1 of the square root of 1 plus x dx. Now we want to evaluate the integral. The integral of the square root of 1 plus x dx is 2/3 times 1 plus x raised to the 3/2 power plus constant. Next, we want to apply the limits from 0 to 1. At 1, we get 2/3 times 2 raised to the 3/2 power, which gives us 2/3 times 2 square root of 2, which that gives us 4 square root of 2 over 3. At 0, we get 2/3 times 1 raised to the 3/2 power, which will give us 2/3. From here, we subtract, and when we do so, this gives us our final answer.